Hey everyone, this is Eric Price from Garage Games, and I'd just like to thank you for joining us today um, in this very busy time of the year. We know that there's lots going on, and to take some time to join us is very valuable for us, and we thank you. Wanted to start off today with a little story and tell you about a little bit about me, about my background and my history. So I have a computer science degree, and I stumbled into computer science. That's one of the reasons why I'm so interested in being involved in education and computer science was because for me it was a bit of luck. One morning I woke up before I was supposed to choose whether I was going to go into college as a general and or pick a major. And when I woke up that morning, Good Morning America had the top five degrees that you should enter into, and they listed number one as computer science, and I had no clue what that was. But since it was number one, I decided to put it down. And when I went to the school to pick up my books right before classes started, I was thumbing through them, and I saw that it said Intro to Programming. And I thought to myself, wow, that's neat. I'm going to also learn computer programming. Because not knowing anything about computer science, I thought that computer science meant I was going to learn how to use a computer really well, as opposed to what I did learn. And luckily for me, it was a good fit, and I really enjoyed it. And best decision I ever made was to go in that direction. I think there's a lot of people that are in similar positions of having an interest in computer science. They're being told computer science is good, but not necessarily knowing what it is. And we've made some really great strides in the last few years, and the participation of the Hour of Code, I think, has played a big role towards that. But I still think there's some more steps to go. So that's my little intro story. Just to let everyone know, your mics, I have it set for a two-way conversation. So feel free to interrupt me while we're talking because we will be able to hear you. And if you have a question, you can ask a question while I'm on a slide. I'm happy to do that. I think we have a small enough group here to be able to do that. So feel free to interrupt, ask questions, and if not, then we'll also have time for questions at the end. All right, let me move on. I want to set the stage here for you and tell you a little bit about us, and that way I think it frames of a lot about what's coming next. So we are GG Interactive. You may have heard of us before as a company called Garage Games. We've been around for 14 years now, and our role has always been involved with helping people make games. We've started off as what's called a game engine company. Our founders made a really popular game in the late 90s called Tribes, one of those multi-million user sale type games in the late 90s, very innovative for its time. They retained the technology, and from that they decided to, after splitting up with their publisher, they decided to see what would happen if they took that $1 million software at the time and just put it online and started selling it for $100 to see what would happen. And it really took off. And Garage Games was started from that. And for many years, we had independent developers, hobbyists, people that normally couldn't afford to make game tech games were using our software to make games. So just a couple of stats here, 170,000 registered developers that have been using our technology throughout the years, all kinds of platforms from mobile games to desktop games, PC, Xbox, you name it. It's the product that we've made throughout those years is an open source platform now, so it's used by many in many circumstances we don't even know. To tell you a little bit about me and our background, we also have our foot in education, which is obviously why we're here today. So I was a department chair prior to my role here at Garage Games. Was also a course director. We have instructional designers on staff, and we've been using our experience in game development to also not only make a curriculum in game development for high schools, but also making game-based learning applications and other educational related products. In addition, we are a real traditional game studio. We do a lot of work in the themed entertainment space. We've made games for the likes of Disney. We've done products for Microsoft, So we straddle the fence as far as being in industry and being in education. And I think that colors pretty much everything that we do. And I think, well, it's kind of a good lead into this next slide. Let me switch, which is that it's all about perspective. And we're coming to you today with this perspective, and I want to kind of put it all out there and tell you what our perspectives are up front, so that you can make an educated decision based on what it is, the choices that you're making. But our perspective is that we're coming from industry. We are career and technology education influenced. What started us down this path was we got invited to sit on a panel for career and technical schools in Nevada. We helped design a curriculum framework for the state, and from that we met a lot of people who are asking us for more advanced curriculum or help in developing it. And we realized that there might be an opportunity for us to get involved from a business perspective. So really our initial perspective in this space was just our personal interest, and it kind of opened the door towards a potential product. So we sell game development curriculum. That's important. I'm going to share with you lots of information about lots of different offerings out there. We do build our material in the way that we think is the right way for and what we would like to see students coming out of K-12 with. So obviously there's going to be a bias there towards things that we're doing that we feel strongly about, but I want to put that out there so everyone's aware. Again, I was a department chair, so I've got some higher ed education experience, which helps us in some ways, and then we also rely on your feedback for helping us in K-12. Professional game developer, as well as the others in this company. And then lastly, we look at computer science as playing a role similar to calculus. So we meet with a lot of schools, and they are using computer science for lots of different ways. Sometimes it's just for a little fun activity. Sometimes it's to integrate into other topics and to teach 21st century skills, and all sorts of different agendas. But our particular interest is to have computer science play a role similar to calculus, in the sense that we do cover a lot of fun topics, but we also try to set a high bar for expectations of what we think students can do, and provide a lot of structure along the lines of doing that. So here you are. The hour of code is over, and I think 2 roads is probably not sufficient to describe the situation that you might be in. We go and visit a lot of high schools, and there are many discussions about what paths to go, and we're going to present many of the paths. I'm sure that you've considered some of them. Maybe we'll expose you to some new paths. Hopefully we'll answer some questions by giving some additional context, but I also think that we will generate more questions, in the sense that we don't necessarily have all of them answered, and a lot of the answers are kind of dependent on your situation, the goals of you, the goals of your school, the experience of your staff, and on a lot of different factors. So there's certainly, I think, one thing to come out of this is there is no single solution. This is a common theme in a lot of software, that there is no single solution, and it takes a little bit of a process and some trial and error to take a guess about where you want to go and then correct as appropriate. All right. So this is showing up a little bit blurry here. I'm going to switch and see if I can get a better picture of this, and you will get a copy of this afterwards, but I want to start with exposing you to some of the resources if you haven't seen them all already. And what we've tried to do here is put together a little taxonomy, and we put it into 3 different categories. So I'm going to start with the genre side here, so by genre. So I think there's a couple different paths that are really useful to go down, and when it comes to resources that you can use. On the hardware side, certainly a lot of people are familiar with Mindstorms and Arduino. Arduino, if you're not as familiar with that, is a microcontroller that has all sorts of, it's a very C-like programming language that has a lot of different add-ons and a very active community. And the idea is to be working on very tangible things that you could sit in front of you on a table, so devices and things of that nature. There's kind of the app genre, which we've included Touch Develop and App Inventor into. If you're not familiar with those, Touch Develop is a Microsoft product that has a very interesting take on visual programming languages, and I like it. But it is certainly different. We've lumped it into the visual programming paradigm, but if you haven't seen how they do it, it is definitely different and worth taking a look at. And of course, App Inventor from MIT, which is really a great way for students to make if you think something more like an enterprise application or some type of clicking and buttons with a GUI for mobile devices. And it uses a visual programming language as well. This is kind of our ballpark where we play in a lot as far as genres go. Everybody, no matter what path people are going down, it seems they try to incorporate some concept of games. I think it's just kind of natural, maybe a human phenomenon, if not anything else. So there's us, and we have a product called DevPro, which is kind of a cradle to grave from the perspective of game industry developers of what it's like to make games, both from design and programming perspective. Code Avengers is one that I've heard a lot of success from last week. Make School is another site that has a game. I'm not as familiar with them. Game Maker, Game Salad, Game Star Mechanic are classics that a lot of people are using. And then finally, one of the first that I saw in this space, if I remember, came out around 2005 maybe, is Kodoo, which was a Microsoft product that originally launched on the Xbox, and it was actually my first view into visual programming languages. So those are some options there. By language, we have a couple of different topics here. I'm just going to kind of skip over that for now, and you can just see them, and you'll get this resource as well. And then finally, one theme that you'll see a lot, if you haven't already, is that there's definitely lots of apps out there, and then you'll see lots of side topics and tutorials that'll help you kind of guide you through, and you'll see less kind of curriculum. So we mapped that out here as well. So in elementary through middle school, definitely there's a lot there from code.org. Those where it says middle there, Project Guts and Bootstrap are two products that are endorsed, or at least supported by or partnered with through code.org. We see that on their site. We also have within our material game design curriculum, which we use as a primer to computer science. So we put ourselves in that category as well. And then in the high school space, we look at CodeHS as being a strong player in this space. The AP Computer Science Principles, which is coming soon, which is definitely a broader, I would say, non-traditional take on computer science in the sense that it's a more computational thinking. And then in the beginner through intermediate levels, we've got some more resources there, including the stuff that we've done. And then fewer in the advanced space, where we list Khan Academy has an advanced JavaScript tutorial where they cover some heavier hitting topics. And of course, we're going pretty far. And then of course, there's a whole continuing education group out there that has a lot of great resources, depending on their model, may or may not work for you. But certainly for you as an educator, that's a great way to help get yourself up to speed on different programming topics. So those are just some of the resources. Again, we will hand this out kind of as a guide for you to use. Let me switch back to my slides. All right. Sorry, all my windows are covering it. There we go. All right, so how do you make this choice? How do you choose what you should teach? And we've thrown up a couple things that we think are important, and we're going to provide some feedback and context to these. Student demand, industry demand, feasibility, and engagement. All right, so I'm going to switch back again to another mind map that we will also send out. So let's talk about a little bit of the industry perspective. As we said, we kind of have a bias in this space, and what we put together for you today is we went through and looked at kind of the big directions you could go next. Let me zoom in on this a bit. Okay, so we're here in computer science. That's where we're starting from. And there's kind of different categories that you could work towards. And, I could see some of these even differing from state to state, where you might have different goals as far as, ultimately where you want students to go into is from a career perspective. Again, this aligns very closely to career and technology schools. I think it aligns as well with comprehensive high schools. So what we did here is we mapped out these different domains, and then within them we created some subdomains. Mostly these are just roles or kind of big areas within that topic. Finally, we went to the language. So I skipped over that language section earlier. And the reason was because we're going to go into more detail here. That's a very common question, which is which language should I teach? And I've heard lots of different answers to this, and I don't think there is any single answer. I think one of the things is you got to make sure that it's helpful that you're comfortable with that language. I think that always helps. But really, the majority of paradigms that you want to teach are transfer very well from one language to another, unless of course that language just doesn't support that construct that you're trying to show. And different languages support different levels of constructs. And I have a slide on that as well. But to continue, what we did here with these numbers is we just took Indeed.com, which is a job site, and we typed in, you can follow the progression, would be, for example, web space front end space JavaScript. And these are the numbers that came out as far as job demand. Now, just to keep in mind, there are people that would post, if we just typed in JavaScript, you'd get a much higher number than this. So all of these numbers are kind of lower because of the additional constraints of putting all of them together. So I wouldn't look at these necessarily as there's only 9,596 front-end JavaScript jobs out there, because if someone excluded the word web, then it wouldn't show up in our search. But from a relative perspective, I think it gives you some sense of the relative size. So in looking at the web is typically broken into front-end and back-end. From my perspective, as coming from a traditional computer science background, I wouldn't necessarily consider HTML and CSS computer science or programming. They're largely they're markup languages, and they're used for configuring visuals on a page. However, JavaScript is a programming language, and so I think that fits a little bit more traditionally. But certainly, what JavaScript does is it manipulates both HTML and CSS, and so therefore they kind of all get lumped into that package there. But certainly, JavaScript is a very popular language and in high demand in the industry. Basically, every business needs a storefront, and obviously, there's lots of businesses whose only storefront is the web. So the opposite of a front-end developer when it comes to web is a back-end developer. And a back-end developer is someone who is largely interfacing with the databases and the servers that run those websites. So we put together some of the languages here. JavaScript in the last few years has really shot up as both a front-end and a back-end language. JavaScript before that was always thought of just a front-end language. So there's PHP, JavaScript, Python, and Ruby, and those are typical backends. Also, very high demand. When you look at the numbers here, these are relative to some of the others are very high demand as far as jobs. Now, MVC, if you're not familiar with that, is short for Model View Controller, and I put that in there because a very popular way to make websites is using what's called an MVC framework. And of those, Rails, Angular, CakePHP, and Django are the most popular. So in the web realm, these are a lot of different options that you could use. You could focus on front end, especially if you think that your students are very heavy in things like the art side and the layout side, and you want to combine that with JavaScript. And then, if you have more interest in higher end programming in the realm of web, then backend is great, and then MVC is almost a little bit more of a way to implement some combination of both. All right, on to enterprise. So there's a lot of enterprise jobs out there, and these are kind of the traditional jobs I think that when I came out of school in 2000 that a lot of people went into. You were either kind of building websites here and there, or you were going to go work for some large company. And these jobs certainly still exist today in great numbers and pretty well across the United States and the world as far as having availability. So we broke that into two categories. You're either a client enterprise programmer where you work on the applications that the users directly interface with, or it's very common to do a lot of server programming in enterprise where those servers integrate and create kind of a centralized system for that company and all of the roles that they are trying to provide with their software. So again, we see an introduction to C# here as a language in enterprise, both for the client and the server. This is Microsoft being very much traditionally an enterprise company. They excel, and they've made C# as a great language. And then also, as you see, one of the big hitters here is Java. So if you're not familiar, in high school, the AP Computer Science is currently using Java. So this is an area that it shines out pretty well. In the game side, this one we had to structure a little bit differently than the others as far as the roles that you play. We split it up into C++, C#, and then we picked two of the most popular game tools out there, which is Unity and Unreal. So again, you can kind of see some relative strength here. Within the game industry, there's a lot of people that don't use these tools, and so having C# or C++ experience will benefit someone who's interested in the game industry path, and not just those tools, right? So Jim's asked me a question here, and Jim's asked me what's the difference in Java and JavaScript. So first off, Java, which just as an interesting tidbit, is an acronym that stands for just another vague acronym. That's true, you can look it up. But Java and JavaScript are very different. The only thing that they really share in similarity is that they are both C-style languages, which is kind of like saying English and Spanish are Latin-based languages. So they have some roots of similar style. But Java is a server-based Java-based is a traditional kind of client and server-based language that compiles down to a bytecode, and then that bytecode is made to run across many, many, many different platforms. That's the strength of Java. JavaScript is largely associated with web browsers, and to some extent that's growing. That's where it started. It's what gives us the functionality of a web page. So those are the two differences. And Java is more like a traditional programming language. JavaScript, we call it a scripting language. One of the reasons is because it doesn't get turned into a highly optimized language for execution. It is a slower language that makes things a little bit maybe even easier for some beginners. All right, so I put another category of things over here. Now, when I did the search for these jobs for things, I actually didn't include the word things in the search, so this one's slightly different. So we just looked at robotics, microcontrollers, and embedded. And you can see kind of the stats from this. I think robotics and microcontrollers, as far as there's a huge explosion over the last couple of years of hobbyists and enthusiasts who are working in home robotics and microcontrollers. I think Kickstarter's played a huge role in this. But as far as industry goes, I think it's still not necessarily growing as quickly as kind of the traditional established software space. And then finally, in the mobile space, it's clear that we are becoming a more mobile world as far as mobile development goes, and this is definitely a rising star. But when you develop for mobile, you kind of get put into two different categories. There's an HTML5 category, which lends itself to borrowing an awful lot from the web world. This is where we see traditional application programming and web programming are kind of merging together. And then there's the native side, where somebody actually uses the programming languages of the mobile device, and the two biggest being Java and Objective-C. And then both of those, when you're making native programs, can make calls to C++. So again, to reiterate, there is no single language to solve all of our different problems in all of our different domains. And you as a teacher can make these kind of decisions when you're trying to figure out what direction you want to go. If you want to specialize in one of these areas, or if you want to do a little bit of everything at a broad level, that's certainly possible too. What you won't be able to do, most certainly in the time frames you're working, is to do all of these in any real depth, because there's just so much. These are each one of these nodes here is a lifetime worth of learning and career. So there's an awful lot to focus on. I'm going to switch back, but if anyone has any other questions, feel free to either chat them, or again, your microphones are on, so you can also just speak up and ask a question. All right, then. I will continue. All right, so I wanted to talk a little bit about a traditional computer science progression. And clearly, we can't necessarily cover all of these topics in all schools, and depending on whether we have folks here, I'm sure, that are middle school, and folks here that are high school, you have different levels that you can get to. But I wanted to at least lay out the traditional path, because what's kind of happening and what I'm seeing from my perspective of the kind of movement that's happened in teaching kids to code is that we're really starting here on the left-hand side, and very much mostly in this kind of visual programming paradigm, which I don't want to diminish that. I think it's actually great. What I want to also present is kind of what happens after that, which so let's start with the left side here, and we'll move our way to the right. So we have these initial topics, which are variables, arrays, and lists, data types, and logic. Then we start moving on to loops and if-else statements, and now we can cover even more logic. Functions, right? We're able to encapsulate functionality into functions. We start covering basic algorithms. So this is where visual programming starts to kind of run out of steam as far as features that can support programming paradigms like stacks and queues. And there's varying levels of support there, and math as well. There's different operators that may or may not be available depending on what tool or package you're using. And then you start integrating media resources, and so we can get to the point with the visual programming and JavaScript and other languages where students are starting to able to make small interactive experiences, things that verge on games, some things that are very simple games like a Flappy Bird or something along those lines. And then, what we're hearing from teachers is that kids are getting a little bit stuck. And part of that is because the way the visual programming languages work is that they're always built on some other language. So a visual programming, those blocks and Blockly are typically built on top of JavaScript. And when students are combining all of those boxes, what ends up happening is those boxes generate JavaScript, and then that JavaScript ends up running through the browser. Where the visual programming creates a little bit of an artificial cap is that we rely on the people creating the tools to encapsulate one or more lines of code in JavaScript, and when we put those together in the industry, we call those macros. So the people who are making visual programming applications are creating lots of little macros that can plug in together and work together. But as far as creating your own macro, if there is one, I haven't seen it yet, that allows you to make your own macros to be able to extend the visual programming language. So that's where things kind of start to slow down. If you have students that are feeling like they're hitting limits with the visual programming language. So another step that you could take students is towards JavaScript. And so JavaScript, being a text-based language, has that initial kind of syntax challenge for students. Semicolons, curly braces, things that look very intimidating. If they're familiar with visual programming language, though, it's a pretty natural transition once people get over the kind of shell shock or maybe initial fear that they have of the text-based languages. And I've had conversations actually with many students where they said after they learned the text-based language, they told me that they wish they would have learned that first, Now, I don't know if that's actually true because they all kind of came from visual programming languages. I think that what they're really saying is, yeah, I wish I had done this a little bit earlier because I kept running into blocks with the visual programming language, and maybe something like Python or JavaScript could have brought me out of that. Okay, so then with JavaScript, we can continue on and start going into some higher level algorithms, like sorting, for example. You could write a sorting algorithm with JavaScript. You could do the same with in data structures is another popular topic that usually comes around here. So an example might be like what we call a binary search tree. These are the kind of things that make Google work. These are very common programming paradigms, and JavaScript will support them to kind of a middle level. And the main reason is the next topic, which is OOP, which stands for Object-Oriented Programming. And visual programming, JavaScript, they're not object-oriented programming languages. JavaScript, you can kind of emulate object-oriented programming, but it's kind of a square peg and round hole scenario. And so if you're trying to teach object-oriented programming with JavaScript, I think it's harder than if you use a naturally object-oriented programming language. Now, object-oriented programming, what that means is that we can organize and map software to in a way that it almost simulates real life. And an example might be the hierarchy and classification of animals, how certain animals inherit the properties of other animals, and we can do classifications. So inheritance is a big topic of object-oriented programming. If you're not familiar with it, just think of it as a way to take very complex things and to break them down into smaller entities so that they can work together. Again, that's where you start seeing C#, Java, and C++ come into play, because those are object-oriented programming languages. They're designed for that purpose. They come with lots of libraries and APIs. They all support GUI, which stands for Guided User Interface. Essentially, when you think of a window, that's what a GUI is. They handle an error handling system called exceptions. I listed that as optional because some people use them and some people don't. Now, continuing, there's a lot to be done there when it comes to OOP. But again, you will run into some limitations, a lot of times performance, which kind of takes you into the next block of complexity, which is topics like how does memory actually work? JavaScript and even C# will kind of isolate you from that topic so that you don't have to think about it as much. Actually, you don't have to think about it really at all well, not at all, mostly from JavaScript. But then with these languages, it's a pretty big tenet of them, and especially C++ on that list is really, really important to understand how memory works, which creates more complexity and more flexibility, but then also more capability to solve problems. So file system, that's another topic we can't quite cover with JavaScript, and in certain things like number systems, and pointers is a topic that is actually a really challenging one for students because it kind of challenges the way you think of things. But it is kind of a key part of how, for example, C++ works. And then kind of the next evolution of this, and we're getting pretty advanced at this point, is you get into things called design patterns. You get into higher level discussions, almost like meta discussions, where the language is secondary and how we organize all of our software becomes kind of the bigger topic. And then I listed artificial intelligence and networking here as, domains that are careers in their own. And I put little stars next to those because I don't want to make it look like we're just railing on JavaScript and we like JavaScript. But you could most certainly teach some artificial intelligence with JavaScript. You can also teach some networking. But with artificial intelligence, for example, you run into a performance constraint with JavaScript. With networking, you'll run into the networking of the web is it handles one of many networking paradigms, and so you can kind of have an intro in networking in that direction with JavaScript, but then again, you will run into some limitations because of the support for it. Okay, continuing on. All right, so Another consideration, and this is, again, this shows our natural bias here, and something that we provide is one of the paths that we introduce students into computer science is through the idea of starting them with game design, which is not a programming, it's not a programming role. It's the same skill sets that you would need to make a board game, for example. So we start, we have students going from game design, and we ramp them up into basic programming and to intermediate programming, and to the point where they're making their own games. And so that's, again, just one path of many, and the path that we kind of go along. All right, so finally, I got two more slides left, and we can open it up for questions here. So why we chose game development? Well, obviously, one, we're a game development studio, so that's one big reason. And then the other reasons here that I think that we chose this path is, well, there's incredible student demand. In fact, that can almost even be a challenge of it. There's a very large demand. Students come in with very high expectations, and we have to get them to kind of build their skills up into this. But we've heard stories of schools that have 32 slots available for a game design or game development class, and they get 300 or so applications. The other reason we like game development is we don't think that we should just be making game developers, but we like the idea that it grows broad industry skills. Games, as they move beyond the very basics and complexity, require things like object-oriented programming. It's a very key part of game development. We also like that the skill sets that you can learn from making games kind of roll into other areas like enterprise with the C# especially, and then a larger audience. And then finally, our student engagement we think is really really high with games. It gives them a lot of flexibility at the sandbox to do things. And then the other pieces that we see, there's this kind of divide when it comes to these spaces. There are students who are, when it comes to technology, there's students that are kind of very driven to the creative side of technology, and there's students that are driven to the programming side. And what's interesting is that the ones that like the creative side often very much dislike the programming side, and then the opposite is true. The students that kind of grow towards the programming side don't like the art side. And so that can be a real deterrent if you're trying to build a class that supports both, because you kind of end up with a class where everybody hates 50% of the course. And so what we like about games is that it can bring those groups together to kind of work together on one project. All right, some recommendations. A lot of these come from my experience teaching in higher ed. Some of them come from things that we hear from teachers that we talk with. One is self-paced labs. One thing that is, I think, a very frustrating experience is, if you've never done it, is to try to have a programming course where everybody is following along at the same pace. Because what you find is there are just vast differences between what students can do, and you'll end up with a pretty small group of people in the middle pack, and you'll have people who are way ahead, who feel like they're spending most of their time waiting for the next line of code or waiting for the next line of instruction, and you'll have a whole other set of people who feel like they're constantly behind. So self-paced labs are a must. If you're giving students and you're doing labs in the classroom, it needs to be either the material itself is self-paced on its own, or you provided them what I've done in the past is just giving people instructions towards a goal, and that those instructions allow them to be more self-paced. Some students will get through these material very quickly, and some students will never finish, and that's the way it typically is. It's very common to have those kinds of disparities. So another one we say is, we think this is important personally, is to teach fundamentals and don't just teach a tool. So there is no Photoshop of software, and when you're teaching Photoshop, you can get away with, say, teaching just Photoshop, and that is a skill set that is very valuable across many, many, many industries. And the second place tool to Photoshop is pretty far away. In programming, everyone's tied for first, and it depends on what you're doing. So teaching the fundamentals is really important. I think when you're teaching and you're making that decision about picking a language, don't just teach the language, teach the fundamentals of that language. And in doing so, you're pretty much teaching the fundamentals of all languages. And then your only limitations might be the feature set for which how far you could go down that path of that last slide. So I would bias towards projects for assessment as opposed to tests. You know, we've written with our product, we've put together assessments in the form of multiple choice questions, but I really recommend putting more weight on the projects than the questions and answers. And the reason is because letting people make different software, I think, is really motivating and drives them, and that's going to create a lot of disparity between what students know. And focusing on their end products, I think, is a really great way to keep them incentivized and engaged, and then also it's a fairer way to assess them. For the middle school audience, I personally think one of the most important things is that they are just having fun, and that when they leave the class, they say that they're having fun, because there's a lot ahead of them. And I think, you know, if you create a frustrating experience, you may have actually closed the door for them getting into computer science in deeper topics later. And so I really, really do feel strongly that that whatever it takes to make it fun in your classroom, go for that. I really like some of the coding without a computer, the coding unplugged concepts, and I think that's really nice and collaborative and a great way to introduce some of these concepts and some of this thinking process, and then keeping the door open for later for more traditional computer science. I put in here, consider sprints, and that word probably doesn't mean a lot to you, but for our industry and a lot of computer science programs or software industries, that's how we run our teams. It's called sprints. You can go look that up and look at sprints and agile development. And I put together a little article on Edutopia about this called project-based production methodologies. And the idea is taking some of the things that we use in industry and applying them to your classroom. In the industry, we assess our employees all the time. I mean, that's part of how we do raises and promotions and create team leaders. And it's this sprint process that we use to not only set schedules and pace for a classroom, it is also a big part of how we do assessment in industry. And I think that some of the things there, I'd be really curious to see people adopt some of those things into the classroom, and that we can maybe learn a bit from each other, how better to handle assessment in the classroom. So if you do a search on Google for project-based production methodologies, it's much shorter than the URL, just to type those to find that article. And also on our blog, we have on our site on gginteractive.com, you'll see the blog link that also talks about similar concepts, and we have some teacher resources there that are pretty independent of our course that you can just use and take a look at. So that's it, and I hope that I answered some questions. Again, I think you're all kind of on independent journeys here, and we'll have different end goals based on your students, their grade level, and your own personal goals as far as where you want to see things go. And I just want to open up to see if there are any questions that I can answer either now, or I put my email address up here as well if you have any questions outside of this. And you can either type them in the chat, or just, I think if you've got your mic on, I should be able to hear you. But if I can't hear you, then you might want to try the chat. I might ask a question here. We got a couple people. If anyone could just write in your chat there, maybe what levels you're teaching, whether it's middle or high school or even higher ed, if we have any higher ed people here. Okay. All right then. Well, if there aren't any questions at this time, please feel free to reach out to us and think of us as a resource. And we certainly are building a product in this space, but we do have personal interest, and I certainly have personal interest as well. This is not just a product for us, it's also a passion. We are engaged in our communities for example, we do a lot, and that's actually what led to this product was our initial interest in reaching out to the communities, and and feel free to think of us as a resource above and beyond that.
Hey,
Yeah,
Eric, what is
yes.
the reason that you decided C# was going to be the best language to teach in your course?
Well, so I think going back to this slide right here. So coming again from our bias from industry and wanting to kind of leave the door open, the challenge we put out in front of ourselves was to create the structure and flexibility that we could start with something like C# that won't have the artificial barriers later. And we felt strongly we could do that, and to be able to have also the higher end features here. And we've reached out and worked with a lot of career and tech schools, and so they want to see the upper bounds be reached before the student leaves the school. So while we aren't against stepping people up from something like visual programming to JavaScript to another language, we wanted to take that approach. And C# of those three down there, we thought was a natural choice. One, C++ gets into requires very early on conversations about pointers and memory, and that can be a very big stumbling block for early entries. C# kind of hides a lot of that for you and handles it for you in a way that still makes the language very fast. And that's important for us teaching games, that it is fast, because that's one of our biggest constraints when you're making a game, is that C# has that. Finally, while C# is a viable language both in the game industry, we also think it's got broad appeal to other things, especially enterprise software, application developer, and application development, and even mobile development. I didn't have that listed on the other, but C# is being used for mobile development as well. There are cross-platform cross-platform implementations of C# that allow you to write C# for mobile devices. And Microsoft has actually announced that they will be broadening cross-platform support for C#. So we think that's also very positive. Java is probably the one question why someone might ask why we didn't pick Java. It does have a lot of these features, and it is part of the AP course. So the reason we didn't go with Java is that Java really isn't a game programming language. It's not used in the game industry. If it is, it's very rare, and it's not really considered part of the family of languages that are in the game industry for one reason or another. And probably early performance might have been an issue. So C# was kind of the natural choice. Any other questions? All right then, thank you for your time.